All right, here's a really quick problem here. We're trying to find this limit. And what I'm going to tell you is this limit's equal to 0. And so what I can see here right off is that cosine x is less than or equal to 1, and it's greater or equal to -1. And I multiply by e to the negative 2x, which is never negative. Just multiply everything there. And so what this does is it sandwiches our function in between e to the negative 2x and negative e to the 2x. And so the function that we're concerned with is right in between, and we're going to use the sandwich theorem or the squeeze theorem, and we go ahead and find the limit of these guys here, e to the negative 2x and negative e to the negative 2x. So this hopefully will come sort of quick to us, what those limits are. That, okay, here we are. Okay, so I'm just going to draw the graph if it's not so clear what those limits are. So this is the y equals e to the negative 2x. And remember, as x goes to infinity, when you have a limit, if the limit is a number, that corresponds directly with a horizontal asymptote. And we see that this function does not hit the x-axis, but it gets very close. The limit here is 0 in both cases. The one above that I have, the first one, is the same as the second, except it has a negative. All right, so essentially what's happening, I can just mark up the paper a little bit, is these outside functions have limit 0. So we can conclude, therefore, the limit of e to the negative 2x cosine x goes to infinity, is equal to 0 by the squeeze theorem. Now, let me sort of ruin what was sort of a quick video by droning on a little bit. Okay, here if I have, roughly speaking, y equals negative e to the negative 2x, what's going on is our function is cosine times e to the negative 2x, and it's like the cosine function, but it has say a magnitude of e to the 2x, sort of like that. I mean, it's a little bit exaggerating when I talk like that, but still. So what's happening is the function is trapped in between these two. It's squeezed in between something like this, not really exactly, but something like this. So that function there is, that's our guy. That's y equals e to the negative 2x cosine x. Right there. That arrow doesn't mean limit. That just means look over there. That's, direct your attention that way. Okay, so that's what our function looks like. And also I want to compare to, I mean, we're already done, but I just also want to point some things out here that are, I think, important, that if you look at the cosine graph, on the other hand, the cosine graph doesn't, we know it doesn't, I mean, if we should know what the graph looks like, and the graph does not have a horizontal asymptote, just because we memorized that from long ago, what the cosine graph looks like. And so here's our regular cosine graph, and there is no horizontal asymptote. It keeps doing that forever. And so what we can say is the limit of cosine x goes to infinity, does not exist. And that is an important point, I think, for me to say. And the reason for that is that means that I cannot use a limit law here. I cannot, when I'm finding this limit of this function, I cannot say, well, okay, I can see, okay, let me focus. Okay, so do you see the limit? Cosine x does not exist. What I cannot do then is I can't just look at this guy and say, e to the negative 2x. I can't say e to the negative 2x, that has limit 0. This cosine x has limit blah, 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 and multiply together. I cannot do that because the limit of cosine x does not exist. So I cannot multiply these two, the limit of e to the negative 2x times the limit of cosine x in like a limit law multiplying two limits. I can't do that because the limit of cosine x doesn't exist. That's why we had to use the squeeze theorem here, because the limit of cosine x doesn't exist. So I had to squeeze e to the negative 2x cosine x in between those two functions. All right, so maybe I can just sort of put a little frame around this to the part that we actually need as our answer, and that's this part. That's our actual answer right there. And the graph of cosine x is, just an extra little note. All right, that's all. Goodbye.